Welcome to our advanced guide on Java backend interview questions, tailored for professionals with 6 to 10 years of experience. At this stage, interviews shift from basic syntax to deeper discussions about system design, architecture, and real-world trade-offs. You're expected to not only know the what, but also explain the why behind your decisions. In this video, we'll walk through 31 practical questions covering core Java, Spring Boot, REST APIs, concurrency, and microservices. Each question is designed to help you prepare for technical discussions and demonstrate your expertise. Let's dive in and boost your confidence for your next interview. Start with core Java fundamentals. At this level, interviewers expect you to differentiate between compile time and runtime polymorphism. For example, static methods belong to the class, not the object, so they can't be overridden, only hidden. This distinction is crucial for understanding how Java resolves method calls. You'll also be asked about the purpose of the finally block, which is used for resource cleanup regardless of exceptions. These questions test your foundational knowledge and your ability to reason about Java's core behaviors, setting the stage for more advanced topics. Marker interface is an interface with no methods. Its primary purpose is to provide metadata to the JVM or frameworks, signaling that a class has a specific property. For example, Serializable and Cloneable are marker interfaces. They allow the JVM to treat objects differently without requiring any method implementation. This concept is often used in frameworks to enable or disable certain behaviors based on the presence of the interface. Understanding marker interfaces helps you design more flexible and extensible systems. Discussing collections, it's important to distinguish between list and set. Lists are ordered collections that allow duplicates and support index-based access, making them ideal for scenarios where order and repetition matter. Sets, on the other hand, do not allow duplicates and may or may not preserve insertion order, depending on the implementation. Hash-based sets offer faster lookups. Choosing between list and set depends on whether you need uniqueness or order in your data. This question often reveals your understanding of Java's collection framework. Common question involves storing null values in HashMap and Hashtable. In HashMap, you can have one null key and multiple null values, making it flexible for various use cases. However, Hashtable does not allow null keys or values, as it predates Java's collections framework and was designed for thread safety. Understanding these differences is essential for choosing the right map implementation in your projects, especially when dealing with legacy code or concurrent environments. When two keys in a hash map produce the same hash code, they end up in the same bucket. Java then uses the equals method to differentiate between them. In Java 8 and later, if a bucket grows beyond a certain threshold, it converts from a linked list to a balanced tree for better performance. Understanding how collisions are handled is crucial because it directly impacts the efficiency and scalability of your applications. This knowledge is often tested in interviews to assess your grasp of data structure. HashMap is not thread-safe, which means it can lead to unpredictable results in concurrent environments. For thread-safe operation, you should use ConcurrentHashMap or Collections.synchronizedMap. ConcurrentHashMap is generally preferred because it allows better parallel access and performance. This distinction is vital when designing systems that require high concurrency and reliability. Interviewers often probe your understanding of thread safety and your ability to choose the right data structures. When using custom objects as keys in a map, you must override both equals and hash code. Failing to do so can result in unpredictable key lookups and bugs that are hard to trace. Proper implementation ensures that your objects behave correctly in hash-based collections. This question tests your attention to detail and understanding of Java's contract for object equality, which is fundamental for building reliable applications. Java Streams Map transforms each element while FlatMap flattens nested structures. For example, Map can convert a list of objects to a list of their names, whereas FlatMap can flatten a stream of lists into a single stream. This distinction is especially important in functional programming and data processing pipelines. Mastery of these concepts demonstrates your ability to write clean and efficient code using Java's Stream API. Optional is a container object that may or may not contain a non-null value. It helps you avoid null pointer exceptions and makes null handling explicit in your code. By using optional, you signal to other developers that a value might be absent, encouraging safer and more readable code. This is a common topic in interviews, as it reflects your approach to defensive programming and robust API design. Runnable and callable are both used for concurrent programming, but they have key differences. Runnable does not return a result and cannot throw checked exceptions, while callable returns a result and can throw checked exceptions. Callable works with future, allowing you to retrieve results asynchronously. Understanding these interfaces is essential for writing effective multi-threaded code in Java. Synchronized keyword provides thread safety by ensuring mutual exclusion and visibility guarantees between threads. Only one thread can execute a synchronized block at a time for a given lock. This mechanism is fundamental for preventing race conditions and ensuring data consistency in concurrent applications. Interviewers often test your understanding of synchronization and its impact on performance. The difference between sleep and wait is a classic interview question. Sleep belongs to the thread class and does not release the lock, while wait belongs to object, releases the lock, and must be called within a synchronized context. Understanding these differences is crucial for writing correct multi-threaded code and avoiding common pitfalls in Java concurrency. Deadlock occurs when two or more threads wait indefinitely for each other's locks, causing the application to freeze. Common strategies to avoid deadlocks include lock ordering, using timeouts, and leveraging concurrent utilities. Avoiding nested locks where possible also helps. Understanding deadlocks and how to prevent them is a key skill for any senior Java developer. In Spring Boot, the default scope of a bean is singleton. This means Spring creates one instance per container by default, ensuring efficient resource usage and consistent behavior across your application. Understanding bean scopes is essential for configuring your application's lifecycle and managing dependencies effectively. Spring Boot allows you to read property values using the @value annotation or @configuration properties. Properties are typically stored in application properties or application (YAML) files. This approach centralizes configuration and makes your application more flexible and maintainable. Interviewers look for your familiarity with these annotations and your ability to manage configurations effectively. To create REST endpoints in Spring Boot, you use the @REST controller annotation, often combined with @get mapping, @post mapping, @put mapping, or @delete mapping. These annotations make it easy to define HTTP endpoints and handle requests. Mastery of these annotations is essential for building robust REST-TFL APIs. Path variables are part of the URL path, such as /users/ed, and are usually required. Request parameters, on the other hand, are passed in the query string like /users, d=10, and are often optional. Understanding when to use each is important for designing clear and intuitive APIs. HTTP 201 means created and indicates that a resource was successfully created, typically after a post operation. Understanding HTTP status codes is fundamental for designing REST-TFL APIs and ensuring proper client-server communication. The difference between HTTP 401 and 403 is crucial for API security. 401 means unauthorized, authentication is required. 403 means forbidden, the user is authenticated but lacks permission. This distinction helps you design secure and user-friendly APIs. REST is stateless, meaning each request must contain all the information needed to process it. The server does not store client session state between requests. This principle ensures scalability and simplicity in distributed systems. A DTO, or data transfer object, is used to transfer data between layers in your application. DTOs help avoid exposing entities directly, resulting in cleaner API contracts and better version control. This pattern is widely used in enterprise applications to maintain separation of concerns. The singleton pattern ensures that only one instance of a class exists. In Spring, the default singleton bean scope is a practical example of this pattern. Singleton is useful for shared resources and configuration objects, but should be used judiciously to avoid hidden dependencies. The factory pattern creates objects without exposing the creation logic directly. This promotes loose coupling, better abstraction, and easier maintenance. It's a foundational design pattern in object-oriented programming and is often used in frameworks and libraries. The O in SOLID stands for the open-close principle. Software should be open for extension, but closed for modification. This means you can add new behavior without changing existing code, making your applications more robust and easier to maintain. The circuit breaker pattern prevents cascading failures between services. If a downstream service fails repeatedly, the circuit opens and requests fail fast temporarily. This allows the system to recover without overwhelming the failing dependency, making it essential for resilient microservices. An API gateway acts as a single entry point for your system, handling responsibilities like routing, authentication, rate limiting, logging, and request aggregation. It simplifies client interactions and centralizes cross-cutting concerns, making it a common component in distributed architectures. Service discovery enables services to locate each other dynamically, which is crucial in environments where instances scale up or down frequently. Tools like Eureka, Consul, and Kubernetes DNS are commonly used for service discovery, ensuring seamless communication in microservices architectures. The CAP theorem states that distributed systems can only guarantee 2 out of 3: consistency, availability, and partition tolerance. Trade-offs are inevitable, and understanding these helps you make informed architecture decisions. This concept often leads to deep design discussions in interviews. Monolithic applications are single deployable units, making them easier to start and develop locally but harder to scale independently. Microservices, on the other hand, are independently deployable, allowing for easier scaling and better ownership boundaries, but they introduce more operational complexity. The right choice depends on your business needs and team maturity. Even as a backend engineer, awareness of front-end frameworks is valuable. Interviewers look for your understanding of API contracts, CORS, authentication flows, and request-response debugging. Cross-functional collaboration is highly valued, as it leads to better product outcomes and smoother team interactions. At the senior level, interviewers are interested in your production experience. They want to hear about real-world scenarios where you made architectural decisions, handled trade-offs, and solved complex problems. Sharing these stories demonstrates your depth of knowledge and practical expertise. Senior interviews often focus on your ability to think through trade-offs. Whether it's choosing between performance and maintainability or deciding on a particular design pattern, being able to articulate your reasoning is key. This mindset sets you apart from less experienced candidates. A strong debugging mindset is essential for senior Java developers. Interviewers look for your approach to identifying, isolating, and resolving issues in production systems. Sharing examples of how you debugged complex problems can highlight your analytical skills and attention to detail. Scalability is a recurring theme in backend interviews. You should be able to discuss how you design systems to handle increased load, what bottlenecks you encountered, and how you address them. This demonstrates your readiness to build systems that grow with business needs. Clear communication is a hallmark of senior engineers. Interviewers value your ability to explain complex concepts in simple terms, collaborate with cross-functional teams, and document your work effectively. These skills are just as important as technical expertise. While knowing Java syntax is important, senior interviews focus more on your reasoning and decision-making. Be prepared to explain why you chose a particular approach, what problem it solved, and what trade-offs you considered. This depth of understanding is what sets you apart. The tech landscape evolves rapidly, and continuous learning is essential. Stay updated with the latest Java features, frameworks, and best practices. Demonstrating your commitment to learning shows interviewers that you're adaptable and proactive. Interviewers appreciate a structured problem-solving approach. Break down complex problems, consider multiple solutions, and evaluate their pros and cons. This methodical approach demonstrates your analytical thinking and reliability as a senior engineer. A growth mindset is crucial for career advancement. Be open to feedback, reflect on past experiences, and continuously seek ways to improve. Sharing examples of how you learned from mistakes or improved processes can make a strong impression in interviews. Collaboration is key in modern software development. Highlight your experience working with cross-functional teams, mentoring junior developers, or leading projects. Strong collaboration skills contribute to better outcomes and a positive team environment. Good API design is essential for building maintainable and scalable systems. Focus on clarity, consistency, and versioning. Be prepared to discuss how you design APIs, handle backward compatibility, and ensure a smooth developer experience. Testing is a critical part of backend development. Discuss your approach to unit testing, integration testing, and end-to-end testing. Highlight tools and frameworks you use, and share examples of how testing improved code quality and reliability. Well-documented code and APIs are easier to maintain and extend. Share your practices for writing clear documentation, using tools like Swagger for APIs, and maintaining up-to-date READMEs. Good documentation is a sign of professionalism and care. In summary, preparing for senior Java backend interviews means going beyond memorizing definitions. Focus on reasoning, production experience, and clear communication. Practice explaining your decisions, trade-offs, and improvements. With these strategies, you'll stand out as a confident and capable candidate. Good luck with your interviews.